Good morning everyone, and welcome to our channel. Today we start by giving you the first notions, the first information about what CNC lathe programming is. First rule, never learn anything by heart, but learn the concept of how the lathe works. Why is this?
I'll explain it to you very briefly.
If you go to work in a workshop, your employer will always have to provide you with the programming manuals. Wow, keep the camera. So, consider that I have one for Siemens, one for Okuma, and it works. Philips, 432 and so on. A manual where I have written down all the basic information and some notes, guidelines that help me to... I remember what the various codes mean when you work in a mechanical tool shop. You can't expect to have only Fanuc, that is, just one brand of CNC. It tends to happen if possible, but it's not always possible. You might have one CS, one Siemens, 4 Fanuc, one Eidenheim, so you simply have to put yourself in a position to understand how the programming language works and then apply the various dialects, a bit like if you go from Brescia to Naples. We both speak Italian, but there are dialectal nuances that make the language slightly different. After a year in a different location from where you came from, you have learned it perfectly. The same goes for programming. I assume you all know what a lathe is, so a rotating piece, a chip, removal process with a rotating piece, and a stationary two-dimensional tool, so 2 axes. The more modern lathes, as you know, also have the capability to mill, which we will see later. Now, let's reason about the 2 dimensions. We have a self-centering chuck and a turret mounted on a cross slide that allows movements from the tailstock to the self-centering chuck. Movements from the tailstock to the self-centering chuck, from bottom to top and vice versa. So I was unsure whether to start with the movement of the axes or the preparatory functions. Basically, there is no rule. Let's start thinking about what the preparatory functions are. That is, what you tell a machine at the beginning of the program. At the beginning of the program, most lathes, but not all, need a special character. Let's say it can be a percentage, usually followed by the name of the program. So it could be P1001 in older lathes. In newer lathes, it can actually be a word like gear. I always recommend commenting the first line of your program in the most detailed way possible. So I always include the name of the client, that is, to whom I will sell the part, the code of the item, and if there are any specifications, that is, design modifications, I include those as well. And normally when a drawing undergoes a modification, that is, for example, we have a ring with an external diameter of 100 and an internal diameter of 40 that is then modified. To an internal diameter of 45, it becomes specification B. I copy the program, make a copy, and keep the old one, just in case they ask for a replacement. After that, we need to start communicating with the lathe. It is good practice to always set a limit on the RPMs, because then we get into the details of cutting speed and fixed RPMs. But when working at a constant cutting speed, if this is our part and we are going to turn it, this is the center of rotation. If we have a speed, an RPM of 1,000 here, as we get closer to the center, we will tend to infinity. Obviously, we cannot run our spindle at infinite RPMs nor at $10,000, because otherwise we would have the machine shaking in the workshop. So normally, depending on the type of machine and the weight of the piece, and some variables related to the grip if it is a G92, S2000, 3000, 4000, 5000, 92S. That is, we tell the machine that at any moment during processing, you can never exceed these G numbers. G92 is repeatable within the program, meaning if we perform multiple operations and want to change the maximum G number for safety reasons, we can do so. So if we have a piece weighing 80 kilo, we can do it. So if we have an 80 kilo piece during machining, we remove so much material, secure locking, and halfway through the process, we want to raise that threshold to 4,000. Some do it. I honestly don't. They put G53, X0, Z0 from memory, meaning they bring the machine to its origins, or on Okuma, you set a G00 to move quickly to X800. Z800, telling the carriage, wherever you are, go to the farthest point possible. And then we will start working from there. It's a safety measure, and it's something I don't like to do much. I foresee an approach to the first movement block, first in Z and then in X. I will explain this too. I don't define this as important, but know that if you find it, especially on Fanuc, I remember this well. G53, X0, Z0 tells the machine to go to its origin point, which is usually high and far from the spindle. After that, we need to start thinking about calling the tool we will work with at the beginning of our piece. So here we have a bit of variation. Normally, when we talk about Fanuc, we write TO101, where 0.1 and 0.1 stand for the turret position number, because you know that a turret, let's make it octagonal to keep it brief. You will have understood that I am not a great designer without CNC. It is made of 8 positions. 10, 12, 16, okay, 4 depending on the tone you work with. You will mount a series of tools on these positions. So if you need a tool for grooving, rather than a tool for external turning, you will call T1 or T2, 01 or 02, meaning the offset, for this little number here. We will talk more about the offset later, just so you know. Because at the beginning of the program, you must call it turret. Attention! Also remember that not all CNCs call the turrets in the same way. So, this is how Fanuc calls it, and this is how Okuma calls it. Siemens T equals 1 ECS. T01 M6 or M16. In my opinion, we Italians discovered CNC, then they stole it from us, but ECS tells you I want you to rotate the turret clockwise or counterclockwise, which is not necessarily the fastest direction of rotation. While Fanuc and Siemens find the turret, I mean yes. They have the turret in position 1, and must definitely call it. They rotate in this direction. If they need to call position 3, they rotate in this direction, and the G codes, depending on whether I use M6, regardless of where the turret is, the turret position I need to call rotates clockwise, M16, counterclockwise, M26, and it is highly customizable in the fastest sense. So here we already have the first differences. Philips 432, which is a very old system, and you might not find it often around. It's very old. Instead, T01013. If this 3 is not there, it doesn't work. This is crucially important for the enabling of the radius compensator. Okay, so we could write program, name, limitation, out of bounds, turret, position. So while it is true that these codes vary, these specific code definitions, however, do not vary at all. It just needs to be interpreted. Another thing at this point, the spindle will need to be rotated, and therefore the self-centering and the piece on which it is mounted. So, to rotate the self-centering, a series of codes must be given. Let's look at the self-centering from the front. So, first code, if the machine has it, not all of them do. Normally the larger ones do, the smaller ones usually do not. The range, that is the gear, neither more nor less, the gears of the car. The car has 6 gears, the lathe has 1, so none for small lathes, 2, or 3. M41, M42, normally, so 2 ranges. If we do not specify it, the lathe will start in the last range set, M42. High range, or M41, low range. What is the difference between the two? The difference is established by the manufacturer and communicated to you. Let's say the manufacturer tells you range 1 M41 works from 0 to 500. RPM range 2 works from 0 to 2000. Normally 0 does not exist, they say 20 RPM. So one might say, well, I always use range 2, what do I care, it works. No, it changes the way torque is developed, so the motor's power. If you need to do, for example, range 1 at 200, 150, RPM will provide all the available torque. Range 2 at 150 RPM. I'm not saying you can stop it with a finger, but if you are already doing a heavy cut, the machine will probably stop. So range 2 is recommended between 400 and the maximum RPM. So if you are used to working with aluminum, you work in range 2. If you are used to making heavy cuts in cast iron or very hard materials, you work in range 1. This will be your experience, and especially the type of work you do. So, gear engaged, range 1, M41, you are on an off-road vehicle going uphill. In range 2, you are in a nice sedan racing down the highway. This is the substantial difference between the two ranges. Once the range is engaged, this chuck, this self-centering one, will need to be put to work. I am the turret. I am watching the self-centering chuck. This is my tool. The insert is mounted on this side, so I need to work in this sense. Okay. This doesn't apply to all lathes because the Italians work in reverse, but Fanuc and Siemens, the sense is okay. But this doesn't apply to all turrets because Italians work in reverse. But for Fanuc, Siemens, or Okuma, this rotation sense, the N4, rotation sense is clockwise when looking at the turret. There are some manuals that say to look at it from the back of the lathe, so counterclockwise. Once you know this on a lathe, it also applies everywhere. It doesn't change. If you want to make it turn in reverse because you've mounted an insert incorrectly, you're threading or drilling because the bits normally turn in reverse. So, always check the tools and pay attention when you input M3 and M4. Use your eyes, don't trust it blindly, or else the parts will jump, which is a pleasure. So this is done, this M3. So M3, M4, rotation, code, spindle, G, and here we have 94, 96, 96. On some machines, a single block M4G is processed. One of these is M42. On other machines, M41 must be programmed separately. Always refer to the machine manual. I want to try to create a course that is a bit more focused on Fanuc and Siemens, but that occasionally it gives you some information, even if not very detailed, about other so-called ISO dialects. just to understand right away that memorizing machine programming is not constructive. You need to learn the concepts. So, M4. The most used is G96. So we write G96 here. But let's see what the others are. We have written G96. G96 is equivalent to constant cutting speed in CNC machining operations. G97 is equal to a fixed RPM such as G. So here I made a little mistake. I ask Worthy. G94.
Let's forget about it. And then I'll explain where I made a mistake. There's a code missing in between. Let's leave the spaces, but let's not forget. So here, M42, M4, G96. My mistake is due to the fact that on ECS it's not exactly like that. Do you see the dialects? So, G96, constant cutting speed, G97 fixed RPM. With G97, all my machining will be done at approximately S150, 150 RPM. So command line to make the spindle rotate. M4, rotation direction G96 or G97, constant cutting speed or fixed RPM. Best communicates. To these two, how many fixed RPM to use, or what constant cutting speed to use. So G97 S150, any machining we program afterwards will be done at 150 RPM. No doubt about it. G96 S150, the RPM, varies with the diameter until reaching a maximum of 2000 RPM. What does this mean? If this, viewed from above, is my cutting insert, and this is my workpiece, in G96 at 150 meters per minute, the RPM of my self-centering will be such that it will cover 150 meters of cutting for every minute of machining at the tool contact point. Okay. Formolina. Vt, cutting speed, equals. I have it written here. I don't remember it by heart. Diameter times 3.14 times the RPM divided by 1000. So diameter times 3.14 times the RPM divided by 1000. From which it derives that NU, meaning number.
The number of revolutions is equal to 1000 times the cutting speed divided by the diameter times 3.14. Calculator. Yes, I am. Sorry. Let me check that I'm still recording. My screen is turned off. Okay, we are still here. I am performing a chamfer. And starting from a diameter of 100. So for a diameter of 100, I ask my piece from my tool to start at 100 meters per minute. My number of revolutions will be 1000. Let's make it quick, because otherwise my number of revolutions will be 1000 for 100 divided. 100, obviously, divided by 3.14. Okay, so at this point we will have 318 revolutions when I reach a diameter, let's say 1. Okay, so not yet, there are. My number of revolutions, be careful, will be 100,000 divided by 1 divided by 314. So 31,000 revolutions. 31,000 revolutions. It is quite obvious that a lathe, perhaps of large size, at 31,000 revolutions, will break apart. You will find screws on the ground. That's why the machine will slow down. It will increase its revolutions as it approaches the center until it stops here. Here is the difference between constant cutting speed and fixed revolutions. If you are already working and are in the workshop, just perform a facing operation to physically feel the machine accelerating as it works towards the center. So even when we create a profile, if we start here at 1000 revolutions, we will be here, that is 1 minute faster. We will be at 500, 600, 700 RPM, like this. I like such a beautiful blackboard in chaos. Obviously. Just as we can adjust the speed, the way the spindle rotates, that is in fixed RPM or constant cutting speed, we can adjust. And we must input it initially first, the way the machine reads a feed rate. Later I will teach you that through the F function we will input the feed rates. You will find in your programs in turning, you will almost always find wording of this type. In milling, you will find wording of this type, that is very large numbers. Here we need to input. Remember, I had previously set G94 and G95 here. So, if I input G94, at this point, my F will be expressed in millimeters per minute, meaning F100 means I have to cover a distance of 100 meters in 1 minute. G95 equals millimeters per revolution, which means, here it is, that for each revolution of my self-centering chuck, my tool will advance by 0.2 mm. So to make 1 millimeter, I need 5 revolutions. The execution speed then depends on the S set. That is the number of revolutions I have given. It follows that if I am working at a fixed constant cutting speed covering 100 m at F2 with a diameter of 20 is much faster than covering 100 m at FO2, excuse me, still 0.2 at the same feed rate at 1000 because the self-centering chuck will turn more slowly. Let's go here. We have reached the point of positioning the holder, so feed information. Self-centering or spindle. These are the preparatory functions that our machine will always need before starting to move the axis. Without these, the machine will hardly move the axis. Attention, with G94 the axis moves even if the spindle is not rotating, so be careful when using it. It's more of a really gripping function. That said, I would say there are other functions like G92 that moves the origin, but these are the main ones. I would say that for now we will stop here. Remember them all, read them. Maybe I will put some links in the description with some manuals to see what to review. Let's see if I show them to you next time. I will also prepare some slides, but I would say that here we have written down everything that is needed. In the next lesson, we will start moving the axis. Okay? I hope I was clear. If not, feel free to ask me any questions on the channel. I can't respond to everyone. I apologize to some. I will respond to others. But let's hope that the questions from some can help others. Well, I can't respond to everyone. I apologize. I will answer some, but not others. Let's hope that someone's questions can help someone else. And study the concepts, not by heart. Have a good day, and see you next time. Bye-bye.